Hi, my name is Daniel Haris bin Muhammad Shukri, 01DE24F1004. Today I will be presenting about sustainable environmental control in coal-fired system power plant. The first one is introduction. Coal power plants are a major way we generate electricity, helping to provide affordable energy. However, they also cause serious environmental problems like air pollution, water pollution from heated water, and a lot of solid waste. So this is the system diagram of steam power plants. First we have coal burn. Then after the coal burn, they will produce steam, and after that they will drive turbine and they will generate electricity from the turbine. There's a lot of environmental issues of coal power plants. First, we have air pollution caused by burning coal and releases harmful smoke and gases into the air. Second, we have thermal pollution, releasing hot water from the plant into rivers or lakes, which harms fish and plants. Third, we have solid waste, caused by leftover ash from the burnt coal that must be disposed of. Fourth and the last one, high resource use, causes the plant use very large amounts of water and energy to run. So we need to have strategies to prevent environmental issues such as air pollution, thermal pollution, solid waste, and high resource use, as I mentioned earlier. So the first one, we need to prevent air pollution. We can install scrubbers, use devices that wash the smoke to remove harmful gases like sulfur dioxide. We can also use electrostatic precipitators. Install equipment that uses electric charges to trap ash and dust particles from the smoke before it goes into the air. We can also switch to better coal. Use higher grade coal that produce fewer pollutants when burned. Second, we have to manage solid waste. Reuse the ash. Use coal ash in making cement, concrete, and bricks instead of sending it to a landfill. If not, we have to have safe landfills. Dispose of ash in specially designed landfills that prevent it from leaking into the soil and water. So the third one, we have to reduce thermal pollution. We can use cooling towers. Build large cooling towers that let the hot water cool down by evaporation before it is released back into the environment. We can also use cooling ponds. Store the heated water in large ponds where it can cool naturally before being discharged. Fourth, conserving water and energy. Recycle water. Treat and reuse water within the plant in a closed loop system to reduce freshwater consumption. Second, we can upgrade equipment. Install more efficient turbines and boilers to generate the same amount of electricity using less coal and water. So, this is the comparison of filtering methods. We have 4 aspects: effectiveness, operational cost, system complexity and maintenance, and environmental impacts and waste. For electrostatic precipitators, ESP, highly effective at removing fine particulate matter with an efficiency often exceeding 99%. However, its performance can be less effective on certain types of resistive dust. For fabric filter, also achieve exceptional efficiency, often greater than 99.9%, and is reliable for a wide range of particle types, including those that are challenging for ESPs. Second, operational cost. For ESP has a higher initial capital cost but generally lower operating cost due to its low pressure drop, which reduce fan energy requirements. The main operational cost for the high voltage electrical system. For fabric filter has a lower initial capital cost but higher long-term operating costs. This is due to higher energy needed for the fans from higher pressure drop, and the recurring cost of replacing the filter bags. Third, the system complexity and maintenance. For ESPs, it's an electricity complex system with sophisticated high voltage components, but it is mechanically robust with fewer moving parts. For fabric filter, is mechanically complex due to the bag cleaning mechanism, but its electrical system is simple. Maintenance is more frequent for bag replacement. So the fourth, environmental impact and waste, has a positive ESPs have a positive secondary effect as it collects dry sealable fly ash that can be recycled for use in cement and concrete, reducing solid waste. For fabric filter, generate solid waste in the form of spent filter bags that must be disposed in landfills, creating an additional waste waste. So the related solutions to Sustainable Development Goal SDG 7. First one, clean energy. By drastically reducing SO2, NOx and particle emissions, we make a dirty energy resource significantly cleaner. This is a crucial step in the transition to a fully sustainable energy system, protecting public health and the environment. Second, affordable energy. While there is an upfront investment, this system prevents massive costs associated with environmental damage, public health crisis, and regulatory fines. This makes energy more affordable in the long run by mitigating external costs. Furthermore, selling collected fly ash for use in concrete creates a revenue stream, offsetting operational costs. The conclusion is coal power causes pollution, but we can control it. Using the right filters makes the air cleaner. This help provide energy that is affordable and less harmful to the environment. It is an important step for a sustainable future. Thank you.